Assalamualaikum warahmatullahi wabarakatuh. Let us continue with the last video related to introduction to trigonometry. Well, you should know that based on the reference angles and its position in the quadrants, the signs of trigonometric functions can be concluded as follows. So if the angle is in the first quadrant, then sine theta, cosine of theta, tangent of theta are all going to be positive. On the other hand, when the reference angle is in the second quadrant, only sine of theta is going to be positive. When the reference angle is in the third quadrant, only tangent of theta is going to be positive. And finally, when the reference angle is in the fourth quadrant, only cosine of theta is going to be positive. So here we have all positive, only sine is positive, only tangent is positive, and only cosine of is positive. And sometimes the simplest way to remember is A S T C. So you have A S T C, which you can easily remember as add sugar to coffee. So this is a simple way of trying to remember what function becomes positive in which quadrant. Now, do you think you can come up with the signs of other trigonometric functions such as cosecant of theta, secant of theta, and cotangent of theta? Now, following this same idea here, I'm sure that you can say for the first quadrant, cosecant of theta will be positive, secant of theta will also be positive, and cotangent of theta will also be positive. However, in the second quadrant, only something that is related to sine of theta will be positive. So in this case, only cosecant of theta will be positive. Now for the third quadrant, only something that is related to tangent of theta will be positive. Therefore, in these circumstances, cotangent of theta will be positive. And finally, only secant of theta will be positive in the fourth quadrant. Okay, now let us try to combine the knowledge that you have gained throughout the previous videos, and we are going to evaluate the following expression here without using the calculator. Okay, so for the first one is sine 210 degrees. So what's the value of that? Okay, so first I'm going to sketch the position of 210 degrees. So this is 180 and you go on a bit more, so this is 210 degrees. And as we have mentioned just now, you can work with the reference angle. So in this case, this is my reference angle, which is 210 minus 180. So this one must have been 30 degrees. Okay, so this must have been 30 degrees. So I need to think of what possible values that I can consider here. So for this one, this is opposite side, adjacent side, and hypotenuse. And we have learned about special angles in the previous video, where you have this special angle where you have this is 30 degrees and this is 60 degrees, and the length of this is given by set 3, 1, and 2. So this is a special, these are the values for special angles which you have seen in the previous video. So now I know that what I want to find is I want to find sine of 210 degrees, and this is equal to working with the reference angle of 30 degrees. But 30 degrees is in the third quadrant. Therefore, you need to have a minus sign because 30 degrees here is in the third quadrant, and we know that only tangent of 30 degrees is going to be positive. Other functions are going to be negative. Okay. Alright, so let me reiterate again. Okay, I'm going to write again the idea which I have just mentioned to you. So basically, I want to find sine 210 degrees, and this is equal to negative. You can work with the reference angle. And why I have negative? Because I know that the function of sine theta in the third quadrant is going to be negative. So negative sine 30 degrees. And based on that, sine 30 degrees, you can refer to this special angle diagram that I have over here. So sine 30 degrees will be 1 over 2. So negative 1 over 2 is the answer. Right, next, let's move on to the next question, which is cos 120 degrees. Okay, so cos 120 degrees. So I'm going to sketch the position of theta. So this is 90 and you move on further, so this is 120 degrees. And again, you can work with the reference angle. So reference angle is this one. Okay, this is the reference angle, and if this is 120 degrees, this must have been, the reference angle theta must have been 60 degrees. Okay, 60 degrees. So again, I need to find out what is the length of this one, opposite, adjacent, and hypotenuse, and I can use the special angle diagram that I have over here to determine the length of this adjacent, opposite, and hypotenuse. Now, what I'm looking for is, I'm looking to find the value of cosine of 120 degrees, and this is equal to working with cos 60 degrees. And because 60 degrees is in the second quadrant, therefore I know the value has to be negative cos 60 degrees. Why is it negative? Is because I know that in the second quadrant, only sine of theta is going to be positive, and the rest, there will be negative. So now cosine of 60 degrees can be obtained by looking at this diagram. So cosine of 60 degrees is 1 over 2. So again, the answer is negative 1 over 2. Okay, next, the third question. So now we move on to the third question. Cotangent of negative 300 degrees. So I'm going to sketch the position of negative 300 degrees, and this will be starting from this point in the clockwise rotation, and it will stop somewhere here. So this is negative 300 degrees. And again, we know that we can work with the reference angle. So my reference angle is this one. And if this is negative 300, therefore my reference theta here will be 60 degrees. Okay. And I need to find the length of opposite, adjacent, and hypotenuse. And again, I can use this special angle diagram to figure out what is the length for each side that I have over here. So now I know that initially what I want to do is I want to find what is cotangent of negative 300 degrees, and this is equal to working with cotangent 60 degrees. and the sine is going to be positive. So cotangent 60 degrees, and the sine is going to be positive, or you don't even need to write down the sine here. Now why is the sine positive is we know that on the first quadrant all trigonometric functions are positive. Okay, so now cotangent of 60 degrees is equal to 1 over tangent of 60 degrees. Tangent of 60 degrees, according to this diagram here, is sec 3 over 1, which is just sec 3. Okay, 1 over tangent 60 degrees is sec 3 over 1. And therefore, this is the answer that you are looking for. Okay, so 1 over tangent 60 degrees is cotangent, so it can be simplified as 1 over sec 3. Alright, thank you very much for watching.